be finding the solutions to a quadratic equation, which is a function, but we're not going to be graphing today, all right? There are three ways to find the solutions, or what they call the roots, or zeros, of a function. The first way we're going to do is through factoring, because we're going to be able to factor. But after that, and that's where we're going to stop before we test, because then it gets even more confusing, so I want to try to test you there, okay? If it's not a factorable problem, you need another form, and then you can solve by completing the square. And yet there's another form called the quadratic formula that you can use to find the missing pieces that you're looking for, okay? But today we're going to do it by factoring. Oh, hey. Okay, first thing you need to see is that we have three different possibilities when we're looking for the solutions to a quadratic equation. You can get one answer because the solution is, or the root is, where does this thing cross the x-axis? In this first example here, that I'm circling with my yellow thingy, if the vertex is sitting on the x-axis, then there is only one spot where it crosses the x-axis, or touches. In the example underneath, if the vertex of a parabola that opens up is above the x-axis, God bless you, it will never cross the x-axis. So far we have a possibility of only one solution to a quadratic equation, a possibility for no solutions to a quadratic equation, and then over here we have a possibility of two. All right, well, the majority of the ones we're going to be working with are going to have two solutions, okay? The first thing you need to know is that the way we find these x-intercepts, which are our roots or zeros of the equation, is by setting it equal to 0. Today, we're going to be working with problems that can be factored. So we're going to factor those things in order to get our possible x's. I believe we had already written this down on Friday. Okay. Now, as a review, the 5 ways of factoring. We always, first and foremost, look for a greatest common factor. If there is a number or a factor in each of the terms that can be removed. Then we had factoring trinomials, which involved undoing FOIL. We had factoring perfect squares, the difference of perfect squares. We had perfect cubes, and we had grouping. 99% of the problems we work will involve greatest common factor, trinomials, or perfect squares. We're really not going to be seeing perfect cubes or grouping, okay? But I wanted to remind you what the ways of factoring were. Like the ways of the Jedi. Okay, oops. Okay, now let's just jump into it. This is a quadratic equation. What makes it a quadratic equation is the fact that there's an x squared term. I think we did this one Friday too, but we're going to do it again. There are 3 steps in the lesson we're learning today to solving a quadratic equation. Write them down. Step 1, set the equation equal to 0. Now something to remember while you are doing this, you want to try to keep your x squared term positive. So it doesn't matter what side you bring what to, but you want to try to keep x squared positive. It makes it easier when you factor. Okay, so step 1, set everything equal to 0. Let's do that. Bringing 6x over to the left-hand side by subtracting it, this is what you get. Step 2, factor. You don't want a squared term in here. You want everything to just be x's. So you're going to factor in whichever way you can. How do we factor this specific thing? The equals 0 part is not part of the factoring. Only the left-hand side. Greatest common factor. What is it?
X.
Okay, so if you factor out an x, this is still the same equation. I've just pulled the left-hand side apart. Okay? And in this, I have created two factors. Now, the reason we do this is because we're operating off of the zero product property, which says that if you're multiplying a bunch of numbers together and the answer is 0, one of them has to be 0. Okay? Well, since there are two factors multiplied to get 0, one of those factors has to equal 0. So here's step 3. Step 1 was set the whole thing equal to 0. Step 2 was factor. Step 3 is set each factor equal to 0 and solve for x. Step 3, set each factor equal to 0 and solve for x. So I take x, set it equal to 0. Then I take x minus 6. That whole group is a factor, and I set it equal to 0. And what are your possible x's? 0 and 6. And we use set notation to write this answer. Okay? X equals 0 is already solved. In the other equation, if you add 6 to both sides, you have x equals 6. Do not put parentheses around your two answers because now you're saying it's an ordered pair, a point that you can plot on a graph. And it's not. X equals 0 or x equals 6. Okay? Step 1 was what?
Set the equation equal to 0.
Set the equation equal to 0. Do it. Subtract it and bring it over to the other side. What was step 2?
Factor.
Factor. Okay, now we're looking at a trinomial. And there's a coefficient in front of the x squared term. Always make sure there's no greatest common factor when there's a coefficient there, which there's not. Okay? All right, if you recall, we had a little trick, a little shortcut, I guess you could call it, to factoring these because they were a little bit more complicated, where we took factors of your first term and put them on top of each other. 2x times 1x gives me 2x squared. And we took factors of 15, like 3 and 5, and wrote them on top of each other. And we did a little cross multiplying trick. If we cross multiply across and down, we get 10x and 3x. Do those two subtract to give me 7x in the middle? If I want plus 7x, it's got to be plus 10 and minus 3, right? And if you did this in the correct order and wrote your answer underneath, then your signs are where they belong. This is the first sign of the first term. 2x minus 3 and 1x plus 5 equals 0. And 10 minus 3 is 7. Okay, so step 1.